Okay, in last class we talked about the concept of vectors. Further, we talked about the little application of vectors, and I told you people once we are having too many vectors, then we will get a matrix. So, matrix, of course, we can do various maneuvers or various output can be obtained from the set of matrix, and matrix is nothing except the data. And data, you can say number of elements or number of values. For example, in this case, if you are considering the revenue and expenses of iPhone or Apple product, you can say iPhone, iPad, Mac, these are the Apple product, or you can say elements of the Apple. You want to know the revenue of these products in 2018, 2019 and 2020. So these are the respective values of revenues, and similarly the cost of expenses, or you can say the production cost of these products in 2018, 2019 and 2020 is like this. So of course these are the 3 by 3 matrix. These are the elements of, this is the first matrix, this is the second matrix. One is telling you about the revenue values, other one is telling you about the expenses values, and each value is kind of an element. And if we are talking the addition, subtraction, we want to, this will tell us the profit. If we are talking about the subtraction, the simple thing, you can see, if we are subtracting, this one is the revenue, or we are subtracting expenses from this one, we will get this output. Okay, and this is telling us about kind of a profit. So nothing is useless. Even simple addition of a matrix, simple subtraction of a matrix is telling us some wonderful and beautiful ideas. Deep learning is playing with data. This is data, and with simple, this is, though you can say 3 by 3 data, but if you are determining the 1,000 products and its revenue, and of course each and every year you are having some balance sheet, with simple click you will get an output for each and every data, or you can say every element, and this is the technically product. Okay, you can manage huge industry. So deep learning with this simple counting application can manage the profit things. Similarly, this is, if we see little bit mathematics, notorious, okay, nostalgia things, this will like this, but it's the simple thing. Okay? Moreover, if you want to know the price of each product, for example, iPhone, iPad, Mac of Apple products, and you want to know the cost of you can say total earning in 2018 for each product, and similarly 19, or you want to sum up the price of total earning for each product, you just need to multiply this single vector with this matrix. You will get this profit. This is very simple. So sometimes we should not ignore the simple addition, simple subtraction, simple multiplication of a matrix. It is deep learning. Deep learning is using these basic data and provide us a wonderful knowledge. So this simple data, of course, forming the dot product element wise, okay, some the element, of course, if we are using the calculator, we are adding the first element, second, and this is kind of some problematic thing. But with the help of matrix theory, we can easily calculate and easily evaluate the desired output in a simple click, or you can say in a very short span of time. I will explain you the many other application of this simple data, but again I would like to emphasize that deep learning is the core of each and everything, especially in this advanced era of computing. Deep learning covers the machine learning, and machine learning covers the artificial intelligence. Artificial intelligence, you can say, just main cover, but core is deep learning. If you're familiar with deep learning, then you can play with each and everything. Machine learning and AI will in your hands, okay? For example, if I am mentally very weak, I cannot stand, I cannot pass the test, even I can have a wonderful facial makeup, other wonderful dress, I will not pass the interview, okay? Internal thing, this deep learning, okay, this is the strong thing. You should know about it. And in case we want to recognize further, we want to interpret some pattern in our daily life, of course, we need a data. And for interpreting of data, we need to know the deep learning. So machine learning will work only once we will have a sufficient data. Why deep learning nowadays booming at the time? Because mobile phone, with the help of internet, we are having, with other business application, huge number of data. Data is increasing. Okay, we are collecting huge number of data. So data is exponentially grows. So the accuracy, precision of the deep learning depend upon the amount of data. So data is increasing day by day. So precision and accuracy of this deep learning is increasing. So of course machine learning say, oh, it's good. Then we will get a artificial, we generally say, oh, artificial intelligence is in progress. For human, it's very easy. Okay, in last lecture I wanted to explain, but I did not talk to people about singular value composition, so I stopped somewhere. So I again started from basic. So of course, this is the cat. Okay, this is some dog, or even it can be a tiger, but it's very easy for us to recognize the difference. But machine could not take it in an easy way, because two eyes, okay, some kind of, you can say hair stuff, two ears, and some, okay, pattern, 4 legs, similar kind of a pattern. Okay, this is some kind of problematic thing for them. If it's one is apple, another is a cat, it is, I told you in last time, basis vector definitely different, but here in case of dot product, it will become troublesome thing, okay? So somewhere, if we again say the different aspects, for example, this is a car, this is some, we can easily say, if someone say Modi is the Prime Minister of Pakistan, it's a fake news. Things are easily, okay, if there is no earthquake or what happened, blast, we can recognize what will happen there, okay? Things become easy for us. But for machine, it's very difficult to understand that it's the blast or it's the earthquake. So, machine learning technique, that important thing, we are collecting the features. Features. Everywhere, in every aspect, you need to understand this. And of course, features can be collected in a very well way once we are having a sufficient data. And once we are collecting the sufficient amount of features with the help of data, then it should work, our machine should work like a brain, and of course it requires a neural network. Like mimic the brain, of course for mimicking the brain, it should follow some neural applications. And there are certain hidden layers. For example, I can see you people, and I want to say something to you, but I could not say. Okay, I am stopping myself. Hidden layers, interpreting, this person is a good, person is a bad. I will not say each time that Numan, you are a bad person, Numan, you are a good person. The problem is this, I am hidden layers is in progress. Similarly, in neural network, many hidden layers, okay, are working. But, for example, computer or machine is observing something, machine want to localize or want to observe that this is the pattern of eye, this is the sea, this is the well, or maybe some another thing, but of course with the help of vectors. Okay, what's the dimensions, extract the features, information, and with the help of norms, calculate the distance. And this neural network, once we are merging too many applications in one sense, then it is giving us the theme that it becomes a network of the neurons. So, of course, once we are implementing the neural network, of course we need a data, and this data is acting as an input, and of course we are training the data. This in my previous first class I told you people, after birth of a child, she tried to learn some words like dad, like papa, mama, whatsoever, because she is listening each and every time this kind of words. If you are using some another way, children are learning Pashto because they are growing up in that environment. They are learning Hinko, they are growing up in that environment. They are learning English, and they can speak English very well because they're brought up in an English environment. So, train. Just like children are trained, here we are training the data. This is the input. Okay? So, output, of course, again, it is the kind of a prediction. For example, if I am speaking in English, though not very good English, but you are predicting because from your childhood you are studying the English courses, that this is English. If I am speaking in Urdu, कि मैं उर्दू बोल रहा हूँ, आप लोगों ने अभी predict कर लिया कि मैं उर्दू बोल रहा हूँ, because this is you trained, your brain is trained to predict what kind of output you are receiving. Okay. So, one thing I would like to highlight again here, this is the two-way operation. One is the forward, one is the backward. In neural network, forward neural network, and we need to play with the backward neural network. In matrix theory, it is very important that if we have some matrix, its inverse should be exist. And inverse should be exist, and of course, if we have some matrix and its inverse is existing, the product of original matrix and its inverse becomes equal to identity matrix. And of course, it's very simple. If we are having some matrix like 1, 3, 2, 6, to know that this matrix is a singular or non-singular concept we studied in our high school classes. If it is a singular, then we cannot solve it, or we cannot get a unique solution of it. Do you know why? Yeah, okay. This matrix become equivalent to 0. For example, we can say 1, 3, 2, 6. We multiply this matrix with some vector, even okay, you are determining, but any vector. For example, I multiply this minus 1, then you will get 0 output. Or you can say this is some kind of a X matrix, 0. Even we know its determinant is kind of a 0, but whatsoever. But this is the singular matrix. But what is the singular? What is the concept of singular matrix? This is very much important. For example, there is some point, and you are moving from this point to somewhere there, and you are covering some distance. Suppose not a matrix, it's kind of a vector. Okay? Vector. And from this position, you are going back. Just put different color. You are reaching to the original position, and this is A inverse. Total work done here almost 0. But in case of vector, we know direction is one thing, another thing is magnitude. Magnitude should be exactly same, though direction is the reverse. Okay, so total work done is almost zero. Basically, what is happening, there is in case of 2 by 2 matrix, we are having the identity matrix like this one. That it can be some change along x-axis, but no change along the y-axis. First row is telling to you. Okay, or even if we are talking about let me explain to you first the concept of singular. Here, if we are traveling in one direction, there is no reverse, then it's a singular way, singular path. There is a some song of Allah Isa Helvi, Kandiyan to Turk Yao, वापस आने का रास्ता नहीं, ठीक है? There is no way back. Then it is a singular. And if there is a way back, reverse is possible, then it is a non-singular. That is the definition of non-singular. Our teacher told us that non-singular matrix can be useful for further process. So, in our deep learning theory, if the system is matrix of problem is non-singular, then we can proceed further. So this is the non-singular concept. This is very much important. Okay, I'll explain further about it. For example, we are having some matrix 1, 3, 2, 7, and suppose this is some matrix A. We want to determine its A inverse. That's why the importance of A inverse, that A inverse is existing or not, because its inverse is possible or not. If it is possible, then we can play with the system. For example, our machine, our robot will go in forward direction, and if we will call back, it will come back. It will follow our instruction. If there is no way back, it will not in our control. Okay, this is the theme of deep learning. So this is A, and we want to know about A inverse. Suppose these are the unknown elements, and we say it's A inverse. And of course, we know that this one equivalent to identity matrix, and we can write it like this. And we can split this matrix. One, 3, 2, 7, A, B, 1, 0. So it is very easy for us. We can apply Cramer rules like in our high school study, or any other method. Okay, we can determine the value of A and B. Similarly, we can write 1, 3, 2, 7. Also B. I think here it can be C. D. 0, 1. So we can eliminate, okay, like in this case. In this case, we want to know ABCD. Okay, very simple. So basically the things are same, like our high school standard, but concept we are learning right now due to blessings of deep learning. Okay, so one another way is the very simple. You can say, if we want to see what's the inverse, what's the image, like we walk forward and what's the inverse of this matrix, we can see it like this. 1, 3, 2, 7, 1, 0, 0, 1. Of course, this one is the A. Here, this is the identity matrix, and of course, we can get A inverse. No, actually, we want to make this A inverse. I just placed here A identity matrix, and I want to replace these values, and I will transform this into identity, and this will become our A inverse. So for this, what I need to do, I need to apply the row elimination method. Okay, I will transform this 2 into 0. For this purpose, I will keep 1, 3 as it is. We will multiply, we apply this operation. Row 2 minus 2 row 1. We will multiply 2 with row first and subtract from the second row. So we will have 0 here. And if we will multiply with 2 3s are 6 and minus from 7, so we will get 1 here. Is it clear? Is it clear?
No, sir. Here we are multiplying 2 with row 1.
Okay, this one is the row first.
Yes, sir.
This one is the row second.
Yes, sir.
We multiply, we want to make this matrix like identity matrix, like this one. We want 0 at this position,
Yes, sir.
So what we do, we will multiply first row with 2 and subtract from the second row. So here, first row we will keep as it is. Okay? 1,
It becomes
0.
0 and 1.
Second row, we will, here it will become 0. 3 2s are 6, minus 1. Minus 6 becomes 1. Here 2
0
minus
and 0
2.
and
Because I multiplied 1 with 2 and minus sign add up in this.
Yes, sir.
So 0 minus 2 becomes minus 2. Similarly, minus 2 multiplied with 0, no effect. So 1 as it is. Furthermore, in next case, we want to get rid of this 3. What we need to do, there is a row 1, multiply with this minus,
R2.
brilliant.
3 R2.
So it will give us 1 0 0 1, and of course second row will not be changed, will not be affected, and
First row will
first
not
row will
change.
become what?
1 0.
First row we multiply this with
Minus
plus
5.
6. 1 plus 6.
Minus 5.
1 plus 6 and
okay plus 6 and then becomes 7.
1 plus 6.
Is it okay?
Yes.
And the other, this one becomes minus 3. In previous classes, I explained the concept of vector geometry. Here you can see this one is our matrix A, and this is the, now this one is identity, and this one is the A inverse. You can see values, image, change, negative sign and diagonal values. Okay, in matrix case, image will be reversed in this way. Sometimes in ambulance, on ambulance there is a written the word, they are English is in okay, inverse way, but in mirror you will reflect it. You will see it in a right way so that you can readability will be improved. Similarly, in deep learning application, sometimes with the help of computing vision technique, you are observing something, but you need to get inverse of it. Okay? For example, inside of mother womb, there is a baby position. So with the camera, you studied in your high school, and with the help of physics, convex lenses, so inverse case, but for you, with the help of computing vision technique, this is the matrix basically, but gives you the further inverse apply, gives you the correct position of it, correct posture of it. Is it okay? So various information you can do with the help of this. Moreover, there is a huge system in ATM machine, or you can say, if we talk a little bit simple here, we can talk about the cryptography. In cryptography, we can say that some person want to share cipher kind of a code words. Okay, in wars, military are using these things at the high level. Even in our daily routine, we are playing certain things. In cryptography, if we are talking about very simple things, for example, there are alphabets of English, A, B, C, D to Z. Total alphabets are, for example, if we are labeled it, 1, 2, 3, 4, 26. Okay. If we want to give some signal to someone and in form of some coded language, for example, to some of our friends or in any area that meet tomorrow. In simple formation, we can write it like, if here in position of M, there is a word 13, E is 5, E is 5, T is 20, ignore the space, okay, ignore the space value, and of course again T is 20, and O is 15, M is 13, O is 15, and R is 18, R is 18, 15, and similarly like 23. This is very easy to decipher. Decrypt. It's very easy. Frequency is, you can say in a way that it's very easy to decrypt. With the help of matrix theory, what you can encrypt this simple meet tomorrow words. Okay, this signal, and this signal can be encrypted. For example, you can consider any random matrix. This is the very simple thing. So I considered 3 by 3 matrix. Otherwise, you can consider if long paragraph you want to encrypt long paragraph. Of course, you will not encrypt with the hand. You need a computing machine. Okay, Python. Just you need to multiply in a second. It will do it. So you can generate even the random matrix of 40 by 40, 100 by 100. It is very easy. So here we are considering some random matrix. For example, 1, 2, 3, 1, 1, 2, 0, 1, 2. This is a random matrix. So you are using it, and in this random matrix, what you need to do, you need to multiply this random matrix here. Transform this into the matrix formation, or you can say vector formation. Okay, for this you can transform this into 3 elements in each, like this. Okay, here you can say this is the first vector, 13, 5, 5. If your word, this signal, coded message is kind of short of length, or then you can add up for here, for example, no O and W, the word finished here, you can add up 0, 0 instead of it. Okay, it's up to you. But in deep learning, you will add up 0, okay, so that it should somewhere. But don't add up any. Okay, thank you so much. Some break for you people. So now you multiply this matrix A with x1, A x2, A x3, A x4. Then my student, you will get some x1, this time A x1. In this case, of course, you will multiply matrix A 1, 1, 1, 2, 3, 1, 1, 2, 0, 1, 2 with first vector 13, 5, 5, and you will get new vector 38, 28, 1, 5, and this is of course new vector. Similarly, you will get x2, A, x2, and you will get new matrix like 105, 70, 50. Of course, this is same, and you will get 20, 20, 50. Okay, all you will get 4 matrix, and at the receiving end information will be like this: 38, 28, 15, 105, 70, 50, 97, 64, 51, 79, 61. My students, this is again the signal, same signal at the receiver end, that is the meet tomorrow. But intruders mean the people who are sitting रास्ते में जो बैठे होते हैं, this is difficult for them to get it. So this is the key matrix, key. Okay, encryption key. If we know this key, of course, if we are sending this message to our friends or our personnel or army personnel, our department fellows, of course they will have this key. This is the standard benchmark key. We set it for sending purpose. Okay. So what will they do? They will use the inverse of A, this matrix, and multiply this A inverse with this one. This A inverse multiply with 38, 28, 15, and they will get back the original one. 13, 5, 5. Are you getting my point? Are you getting it? Okay. See, this one is a matrix. This one is matrix A. It is at the sending end. Okay, I am dispatching some information, some signal.
encryption point है
Yes, please.
और ये
No.
उसकी encryption key होगी.
Yeah, encryption key. Beautiful. Encryption key. This is an encryption key. Okay. You can keep it in any way. Okay. You can change its value, its size, everything you can do. Yes, please. No. There is no question awkward. Okay, come on.
सर ये आपने कॉलम में लिया हुआ है ना, ये जो हमारे पास जो वो है, ये हम रो में क्यों नहीं ले सकते सर?
Okay, this one you said that meet tomorrow. I consider in a column formation. Actually, if you will consider a row like this, okay, this formation, your multiplication order. Do you know what is the matrix multiplication order?
सर
Row into column.
Yes, sir.
That's why we are considering it in a column. Otherwise, it does not matter. If we are taking just transpose of it, then we will transform this column into the row or row into the column. But due to the reason that multiplication, matrix multiplication follow the row into column pattern, so that's why we are considering it in a column formation. Because we will have this this one as a key in a matrix form, and it will follow some row into the column, because we are considering the if we are considering a column with 3 elements, of course there are basically 3 rows. Here there are 3 rows. Basically there are 3 rows. Okay, and in this matrix we will keep the matrix with 3 rows. Okay, so one column we will multiply it and we will get encrypted values. And at the receiving end, at the destination point, we will use the inverse of it. Inverse of this matrix A, we will get back this one, original one. So deep learning is playing the cipher and decipher content very nicely.
सर
Yes, please.
आपने कहा था कि नॉन सिंगुलर मैट्रिक्स
Yes,
यूज
please.
होंगे डीप लर्निंग में.
Yes.
अगर सिंगुलर मैट्रिक्स
brilliant concept. Just please complete your question.
वो सिंगुलर मैट्रिक्स बन जाए जो हम कोड दे रहे हैं, जो आपने मीट टुमारो का लिखा है.
Yes. Wonderful. If it is, I told you, you can add up 0 values in it. Okay, you are here, for example, in the this one you want to see, for example, even all are 0 here. Tomorrow is 0. Only meet. You want to keep only meet. Then you can use. You should use a matrix of 2 by 2 as a key matrix. You should change the key according to the
कि
requirement.
फिक्स नहीं होगी सर हर.
Key, see, if we are a people, we need to set the key that it should follow the 2 words, this length, this kind of thing, okay? So, this is the benchmark thing, key. You will fix it for particular goal, particular purpose. It will not be standard for each and every conversation, okay? For some part, otherwise it will be leaked, okay? Key will be even hacked too. Okay. So, but again, the interest of a question is this: if in what will happen if there is singular case, okay? Then there are certain possibilities, and the beautiful possibilities of this deep learning. And in this deep learning case, once you are dealing with okay, there are 2 possibilities. If the non-singular, it's okay. Non-singular case, it's okay. What will happen if there is a singular? In this situation, we will apply pseudo-inverse. And pseudo-inverse will follow this pattern. I will teach you this, but just after the deep learning complete code, okay? Of course, there are certain things which will be managed with the help of pseudo-inverse, okay? And in the case of singular, it can be worked once, for example, you will have some matrix like 1, 1, 2, 3 matrix, and there are number of rows, okay? Here in this case, variables are less. Variables are less, but elements at this point you can see that the elements are features. Features value here we have 2 variables, and in this case you can say that A inverse of course does not exist here. If there is a matrix, A inverse does not exist. This is kind of our determinant case. Our determinant. This is the case. Once the system is our determinant, then we applied pseudo-inverse. And this is the pseudo-inverse with the help of which we get the conclusion matrix. Okay, final vector for decision purpose. Deep learning decide. Many cases, okay, usually you can say non-singular. In the linear case, it is very easy. But our most of real life applications, you can say following the singular dead end. Okay, sometimes even deep learning is working that someone is going to becoming dead. How it can? People are trying how to wake him up, though it is not in practical, but they are trying. They are trying because using the person previous data from his childhood to his death. So try to prepare some clone. Just need a data. All of person, human life data is required. But still, you know, Almighty Allah, okay, some kind of creatures. We are supreme creatures. It is not easy to develop, but this is the case, our determined case. Yes, this is the our determinant case. In this case, usually you people could not get the A inverse, and learning rate, okay, system, you can say that more equations than the variables. Here equations are, if we write these in number of equations, problems are more, variables are less. For example, here we can write, if there is a 0 or maybe some 9, we can write x1 plus x2 equal 9, or minus x1 plus x2 equal 9, or 2x1 plus 3x2 equal to 9. My children, see, basically equations are nothing except the problem. Problems are larger than the variables. Okay. For example, in deep learning, we are developing some robot. Robot is even, for example, some drone. Drone is collecting the pictures, even can be used for the throwing of water on the fire, for multitasking. Multitasking system. We are developing multitasking system. Of course, this is the singular case. In this case, A inverse does not exist. If inverse exists, very simple and unique solutions. Okay? There are infinite many solutions. In this case, our determinant case, many solutions, then we apply the pseudo-inverse. And the applications of pseudo-inverse are huge. So we can use it for several purposes, and this pseudo-inverse will help you to conclude the nonlinear